Okay, so this is the vodcasted lesson for Unit 3, Lesson 1, Chemical Equations and Balancing. So if you look in your notes packet, it'll be the first lesson in your notes packet. In this unit, what we're going to start talking about are chemical equations. And again, you'll notice in your notes packet, there's 5 objectives. Those are the things that you should be able to do after this lesson. And then you're also going to have some vocabulary terms there. So anyway, let's just go through the notes for this lesson and some examples. It's open. Okay, so let's go through some of these terms. First of all, a chemical reaction is something that happens when you take two substances and they interact chemically. So for example, if you had hydrogen, reacted it with oxygen and formed H2O, the hydrogen and the oxygen are combining to form a new substance, which is water. So the chemical reaction is the process of that happening. The chemical equation is the letters and numbers that we put on the paper to indicate what's happening. Hydrogen reacts with oxygen to form H2O. So we have substances changing into other substances, and that is what we call a chemical reaction. So the reactants here are the things on the left side. So we have reactants, and then the products are the things that we have on the right side. So reactants turn into products. This is what we refer to as a chemical change. Things are being changed into new substances. Physical changes are simply changes to the appearance of the compound. So for example, if you have ice water and you change it into liquid water. So physical changes don't change the chemical makeup of the substance. So if you have a chemical change, what that means is you are going to break some bonds and make some new bonds, forming a new substance. So let's go through some examples of writing chemical equations. At this point, this is nothing more than writing formulas, which you already know how to do. So what we want to do is practice writing some formulas for, whoops, let me get my pen back. We want to write some formulas for these things reacting together to form those things. All right, so lithium chloride got an IBE ending, so we're going to say lithium plus chloride 1 minus. So if we crisscross, we get LiCl. Reacts with, we're going to put a plus sign. Sodium sulfate, ATE ending, so that's polyatomic sulfate. Sodium is Na with a 1 plus charge. So if we crisscross, we get that. If you're still having trouble writing formulas, go to the Quizlet practice and do some of those. Lithium sulfate, so lithium 1 plus, sulfate, so crisscross, Li2, SO4, and then sodium chloride, NaCl. So you have a basic chemical equation representing a chemical reaction. And people use those terms, equation and reaction, interchangeably sometimes. All right, let's do the next one. We have iron reacting with oxygen. I'm going to write this as O2 for right now, and we'll explain in the next lesson why that is. And we have iron 3 oxide, so we have iron with a 3 plus charge, oxygen 2 minus, so we have Fe2O3. The next one, we have silver nitrate. So silver, I would tell you, is 1 plus. Nitrate, NO3 1 minus, so we have AgNO3. Hydrochloric acid is HCl. To produce, so we write our arrow. Silver, oops, this is a little bit of a mistake here. That should say silver chloride. Sorry. So we have silver chloride, and then nitric acid would be HNO3. So again, what we're really doing here is just writing the formulas, the reactants on the left, the arrow meaning to produce or yields, and then the products on the right. All right, so what we're going to talk about in the second part of this lesson is balancing chemical equations. So before we do that, let's just talk about what law of conservation of mass is. So law of conservation of mass, you should know the definition and you can see it in your notes packet. It basically means whatever mass you start with on the left, you have to have the same mass of products when you're finished. So if everything reacts perfectly and you put 10 grams of A and 5 grams of B, you're going to have 15 grams of the product AB. So matter can't be created or destroyed, it's simply rearranged to form something new. So what that means with a chemical reaction is that since each of these elements has a specific molar mass, in other words, hydrogen has a molar mass of 1, and since we have 2 of them, the total mass of that hydrogen would be 2 grams per mole. Oxygen's mass is 16, so that would be 32 grams per mole. Water's mass is going to be 18 grams per mole. But what we need to do is make sure we have the same number of each element on the reactant side as we do on the products. So if you count these, on the reactant side we have 2 hydrogens. Over here we have 2 hydrogens, so that's good. Remember, the subscript tells you how many you have. The oxygens on this side we have 2, and over here we only have 1. So what we're going to do, and the only thing we can do to balance this out, we're going to add a coefficient or a number in front of that water molecule, and it has to be a whole number. So if we want 2 oxygens, we're going to put a 2 there. So what we have now is 2 oxygens. Now coefficients do 2 things. They distribute to everything, every element in the formula, and they multiply. So now we're going to have 4 hydrogens. So now we've got to go back over to this side, and we're going to put a 2 in front of that hydrogen, so we have 4. So we have 4 hydrogens, 2 oxygens, 2 oxygens, and that equation balances. So what I'm going to do is make another vodcast that goes over specifically just balancing. We'll address this in another vodcast.